In this video, we're going to learn about the quadratic formula. So to start off, let's talk about what exactly is the quadratic formula. What's it good for? Well, the quadratic formula is a formula that helps us solve quadratic equations. So here's how it's defined. The solutions to a quadratic equation of this form, ax squared plus bx plus c equals 0, where a, b, and c are just coefficients in the equation, real coefficients. The solution to that quadratic equation is given by the quadratic formula, which we'll write below. X equals, hang on tight, this is kind of a big formula, but don't worry, it won't be too bad to remember once you've worked a few examples. So it has a fraction, and that fraction in the numerator, it goes like this. We have negative b, so negative of the coefficient on the x, then plus or minus the square root of an expression on the inside. And the expression on the inside is b squared, then minus this product of 4 times a, the leading coefficient on the x squared, and also times c, the constant in the equation. So that's all under the square root in the numerator. And then in the denominator, we have 2 times the leading coefficient a. And there we go. That is the quadratic formula right here. Well, let's box it because it's super important. It's what this whole video is about. And now let's work a few examples in which we're given a quadratic equation and we use the quadratic formula to find the solutions. Alright, so here's an example. We want to use the quadratic formula to solve the equation 6x squared plus 7x equals 3. And don't worry if you don't remember the quadratic formula from the previous slide. Again, it's a lot to take in, but we've got it written down in this box here. So what we need to do is we need to convert this quadratic equation into the form ax squared plus bx plus c equals 0. And then we can apply the quadratic formula, which takes this form. Okay, so first step is to convert this equation into this form. Now you'll notice that this equation is almost in this form. We've got our 6x squared, that's kind of our ax squared here, then plus 7x, that's our plus bx, and then the only difference between these two forms is that we need the right-hand side to be 0, and right now the right-hand side is 3. So let's write down this equation and manipulate it so that the right-hand side turns into 0. So 6x squared plus 7x equals 3. What can we do to get that right-hand side to be 0? Well, we can just subtract 3 from both sides. So let's do that. Subtract 3 from both sides, get 6x squared plus 7x minus 3 equals 0. Great, so now this is in the form that we want, and let's just write this down again, color coding according to what coefficients we're talking about here. So ax squared goes along with this 6x squared. So 6 is what a is. 6 is a. So we write that down, 6x squared. Let's also just make a note on the side so that we don't forget. 6 is a. A equals 6. Okay, then we have a plus 7x. So plus 7 is going to be our b value because that's a coefficient on the x. So plus 7x. And again, let's write that down on the side to be very explicit. B equals 7. And then how about the last term here? We want to write it as plus c. So let's write it as plus negative 3. Minus 3 is the same as plus negative 3. Okay, so negative 3 is our c value. C equals negative 3. And that's all equal to 0. Okay, perfect. So we've got our quadratic equation in the right form, and we've got our values of a, b, and c just taken from the coefficients here, and we can just stick them right into the quadratic formula to find our solution. So let's go ahead and do that. X equals, it's a fraction, and then on top we start off with negative b, b is 7, so negative 7, then plus or minus square root, and then we've got a full expression inside the square root, that's b squared, so 7 squared, and then minus 4 times a is 6, so 4 times 6, and then times c, and c is negative 3, so times negative 3. Let's extend that top there a little bit to keep everything inside the root. And then on the bottom we've got 2a. So 2 times a, and a, as we know, is just 6. So 2 times 6. Now it's just a matter of computing what this expression is. Let's write it down again and compute. So x equals -7 plus or minus the square root. Let's simplify that expression inside the square root. 7 squared is 49. And then minus 4 times 6 times minus 3. Why don't we work that out on the side here? Minus 4 times 6 times minus 3. Well, minus 4 times 6 is minus 24. And then multiply that by minus 3. 2 minuses, so those cancel, and we're going to have a positive result. The result is just 24 times 3. And 24 times 3, if you multiply that out, you should get 72. So that's what's going here. Then plus 72. All right, and that's all over 2 times 6, so all over 12. Let's continue to simplify this. So that's equal to -7 plus or minus the square root of, what's 49 plus 72? Well, if you add that up, you should get 121. All right, and then divide by 12. We can simplify even further because 121 is a perfect square. 121 is 11 squared. So the square root of 121 is just 11. So we get -7 plus or minus 11 over 12. So we've got two solutions here. One solution is x equals -7 minus 11 over 12. And the other solution is x equals -7 plus 11 over 12. And let's just go ahead and simplify both of these results. So this one with minus 11 over 12, that simplifies to x equals -7 minus 11 is -18 over 12. And we can simplify that even further, divide top and bottom by 6, and you get x equals -3 over 2. And then our other solution, -7 plus 11 in the numerator, gives us x equals 4 over 12. And if we simplify that, just divide by 4 on top and bottom, we get x equals 1/3. So these are our two solutions here. X equals -3 over 2, or x equals 1/3. All right, here's a second example. We want to use the quadratic formula to solve the equation x squared equals 2x plus 5. And now that we're a little bit more familiar about how this whole process works, let's go ahead and try to move through this example a little bit more quickly. So we have x squared equals 2x plus 5. First thing we want to do is manipulate this equation to get it in the form ax squared plus bx plus c equals 0. So let's just move whatever's on the right-hand side over to the left-hand side so that the right-hand side becomes 0. And to do that, we're going to have to subtract 2x and subtract 5 on both sides. So we'll have x squared minus 2x minus 5 is equal to 0. All right, great. So now we have this form ax squared plus bx plus c equals 0, and we can tell what our a, b, and c are. A is just the coefficient of x squared, which is just 1. So a is 1 here. B is the coefficient on the x, so b is -2. And c is the constant. C is -5 here. And we can just run this through our formula now. So x equals a fraction, and in the numerator is -b, so negative of -2, which is +2, and then plus or minus. We've got a square root. Inside of that square root is b squared, so let's write that. That's -2 squared, and then minus 4ac, so minus 4 times a is 1, and then times c is -5. Go ahead and clean up that square root, that fraction, and on the bottom we have 2a, so 2 times a, which is 1. And now it's just a matter of computing this thing. All right, so let's do that. X equals 2 plus or minus the square root of whatever this expression is. So let's compute that. -2 squared. -2 times -2, well, that's a positive because negatives cancel out. And then 2 squared is just 4. So we've got 4. And then minus 4 times 1 times minus 5, let's work that out on the side. Minus 4 times 1 times minus 5. Minus 4 times 1 is just minus 4, so we've got minus 4 times minus 5, minus times minus cancels out, then 4 times 5 is 20. So 4 plus 20. And that's all over 2 times 1, so all over 2. Let's continue simplifying that. So x equals 2 plus or minus square root of 24 over 2. And we can simplify this root a little bit. X equals 2 plus or minus any perfect squares that multiply into 24. Well, 4 does. We have 4 times 6 is 24. So root of 24 is same as root of 4 times root of 6. That's all over 2. And let's move this up here so we don't run out of room. So x equals 2 plus or minus root of 4 is 2, so 2 root of 6 over 2. And now we can just divide each of these terms, the numerator by the denominator, which is 2. So x equals 2 over 2, or just 1, plus or minus 2 root 6 over 2, which is just root 6. So there we go, there we have it. X equals 1 plus or minus root 6. Alright, so here's our final example. Use the quadratic formula to solve the equation 2x squared plus 3x plus 4 equals 0. And you'll notice that's already in the standard form ax squared plus bx plus c equals 0 that we want. So let's just write it down again. 2x squared plus 3x plus 4 equals 0. And immediately we can identify what our a, b, and c are. A is just 2, b is just 3, and c is just 4. Let's stick these in our quadratic formula now. So x equals a fraction, and the fraction consists of negative b, so negative 3, then plus or minus the root of an expression which is b squared, so 3 squared, then minus 4 times a, which is 2, then times c, which is 4. And that's all over 2a, so all over 2 times a, which is 2. We continue computing now, so x equals negative 3 plus or minus root of 3 squared is just 9, so 9, and then let's compute this minus 4 times 2 times 4 on the side. Minus 4 times 2 is minus 8, and minus 8 times 4 is minus 32. So we've got 9 minus 32 on the inside, and that's all over 2 times 2, which is 4. Continue simplifying. X equals negative 3 plus or minus root of 9 minus 32. If you do that subtraction, you should get negative 23. That's all over 4. But hold on, look at that. That's a negative inside of the root. And the root of a negative number is not a real number. We can't take roots of negative numbers and stay in the real numbers. So that's not a real number, which means that there is no real solution for x. Just no real solution. And that's our final conclusion. This quadratic equation just doesn't have any real solutions. Great, so now we know how to use the quadratic formula to find the solutions to a quadratic equation. We saw that the number inside of this square root in the quadratic formula determines whether or not the equation has solutions. So in the future, we'll learn more about how that number, called the discriminant, controls the number of solutions to a quadratic equation.